So one intimidating factor of being a brand new 3D printer owner is the print profile. And we know that a print profile is the code that talks to the machine and tells it how it is to print a specific part. There's lots of aspects to a print profile, and it can be very tricky to understand what each one does. But at the raw basics of a print profile, there's really only one or two aspects that determine how well the printer is going to print. One of those aspects is the speed that it's actually moving and extruding the filament, and the temperature at which it is extruding that particular filament. If you can get the right temperature, the right speed on your machine, you should have successful prints all the time. If we look at a CNC machine, they also have those two basic functions that they need to control. They call them speed and feed. So how fast the bit is rotating and how quickly it's plunging in or cutting that material. If the CNC machinist gets both of those two aspects correct, he's not going to be burning out bits, he's not going to have rough edges, and he's going to be able to clean that material properly. And that's what we want to do with our 3D printers. We want to be able to extrude the filament at a proper rate, at a proper temperature, so that our models come out smooth and accurate. So if you've printed out the test cube and you believe that your machine is mechanically sound, then we can go ahead and move on to starting our very first print profile from scratch with whatever material and whatever nozzle size that you have. So let's get going. Software that I'm using is Simplified 3D, but all of the popular slicing programs out there should have these same basic functions to replicate what I'm doing. So first thing is I need to add in our Sidewinder machine that we're going to be using. Now we have our Sidewinder installed, and profiles for this machine have already been created from Simplified 3D, and they're in processes right here. But we want to start from scratch, so let's open these up. And in here is our settings that they've created. They've created a PLA one, an ABS one, PETG, and so on. So they've created these. I'm going to do PLA. I need to open up the advanced settings because in here, these are the profiles that I want to change. These are the ones that we're going to control. So first of all, the extruder that I'm going to be working with is a 0.4 millimeter nozzle. The extrusion multiplier, I want to be 1. The extrusion width, I want to be auto. The retraction, I'm just going to leave. The layer height, I'm going to be doing a 0.2 millimeter layer height. Now for this model, this test model, it's going to have 0 top layers, it's going to have 1 bottom layer, and it's only going to have 1 shell. Now layer settings, first layer setting, I'm going to have it 100%. The first layer width is 100%. And the first layer speed is also 100%. The first layer speed we will be adjusting after we've started building the profile in the machine. Now, in addition, we're going to have a skirt and brim, skirt or brim. There's going to be just 1 layer. It's not going to be offset from the part. And let's give it 4 lines or more. 4 is fine. Infill is going to be 0. There's no supports. So under temperature, the heated bed is set for 60. That's fine. The extruder is set for 210. I'm going to adjust that. I'm going to remove that. I'm going to add 200. On whatever material you're going to be using, they give you a temperature range. You can pick multiples or just go right in the middle. And for PLA, 200 seems to be right in the middle, so that's where I'm going to sit for now. Cooling, I want the cooling fan to run because it's PLA. Under scripts, there's a starting script and an ending script. Starting script I'm going to change. This is the G code that I like to use. It's in the description below if you want to use it. The ending script, I'm just going to leave theirs alone. Speeds, this is where all of the adjustments that we're going to be doing for this particular model are going to happen. It's the beginning of our print profile. So first thing I want to do is I want to pick a default printing speed. Now, default printing speed that is realistic for this type of machine is about 60 millimeters a second. You can make it 100, you can make it 80, you can make it whatever you like to begin with, because we're going to be adjusting it on the machine and dial in what this printing speed should be. Now, the underspeeds, I don't want to have any underspeeds right now. I don't want the software controlling how fast my machine moves. I want to do that at the machine itself. 100%, 100%, 100%. Now the travel speeds for the machine, this machine can move quite quickly, so I'm going to speed that up. And here we have another override to slow the machine down. I don't want that right now. I'm going to turn that off as well. Now our last step is to figure out the filament diameter. Now 1.75 is the sort of the size it's supposed to be, but it's not the actual size. So we are going to go to a website that's going to help us walk through measuring and putting in the correct number here for the filament that we're using. Once you get to this website, and I have the link in the description below, it's a great tool. Scroll down and you'll see measure the filament diameter. You can quickly read this. It'll explain how to do the measurements. Once you do the measurements, you're going to add the measurements in here. And then this is going to give us an average size or diameter of our filament, and that's the number that we're going to put into that spot. So let me do that now. So now it's given me an average of 1.69. So that is the number that I'm going to put in. Now I'm going to take that number that the website gave me, I'm going to type it in right here, and then I'm going to save this beginning profile. So now that it's saved, we want to go ahead and apply a model. Now the model that I've created is a 35 millimeter by 35 millimeter by 60 millimeter tall block. And where I position the block could be in a couple of different places. I like to put it in a corner. The reason I want to place it in one of the four corners is it's right underneath one of the adjusting screws. So when that first layer happens, I can make some adjustments to make sure that it's level in that spot. Now, one thing that I want to have happen is that I'm going to adjust this model's rotation, and I want to rotate it 45 degrees. The reason why I want to turn it 45 degrees is because I want all of the motors running constantly as it's printing. I don't want it to have a time where one set of motors are stopped and it's moving in one direction or another. I want the machine completely running constantly. Now once that's been set up, let's go ahead and let's slice this. So here's what's going to happen. We're going to apply this to our SD card. We're going to put it in the machine. The machine is going to start off by printing the first layer and working its way up. But as it's working its way up, what I'm going to do is I'm going to go in and adjust the speed at which the machine is actually running, so the default printing speed. And as we adjust the default printing speed, we're going to start to see how the machine is extruding the filament with its movements, and we want to get it as smooth as possible, the same as the CNC machine cutting that aluminum. Let's go ahead and apply this to an SD card and get it on the machine, get it running. So now that I've got it actually running on the machine, I'll take a close look at the first layer and see if it's sticking down properly. Sometimes the speed that I've chosen as my default speed is just too fast and it just is unable to lay it down well on the bed, and I'll just cancel the print and adjust the speed from there. But so far this one seems to be printing fine, so I decide I'm just going to let it run. So as it's running, I'll let it run the outer perimeter up to maybe 5 millimeters tall, something like that. You can decide however tall you want, so at least I've got something to look at. Then I'll get into the speed settings on the machine, and I'm going to turn it down in 10% increments, so good jumps down. I'll take it down 10% at a time and notice the changes. And then once I get up to another 5 millimeters or whatever you decide, I'll adjust it again down to the next 10%. Also during the process, I'll speed the machine up too. I'll take it up so I can see the big contrast between the slower speeds and the faster speeds. You might get a better sidewall, you might get a better transition around a corner, who knows, but we have the ability to make the adjustments, so we're going to make the adjustments now. I won't print the piece all the way to the top. I'll print it until I think I've got enough transition spots there to take a look at and potentially pick a speed from, so I'll just cancel the print and take a close look at it. Now I noticed on this particular print that the slower speeds, obviously I was getting some smoother areas, but the faster the speeds were, I was getting a hard bump around the corner, so I could physically feel that bump. I was getting some funny lines in around the transitions, but the thing was that as I went slower, the sidewalls were starting to show some ridges, almost like it was picking up the steps in the motors and transitioning that to the print side. So this particular print, the 80% had the smoothest sidewall, it had the nicest transition around corners, and the first layer laid down fantastic. So my bed's flat and the extrusion's good, so I'm going to go ahead and transition into a different model now. Okay, now that we have our speed adjustment, let's go in and make that change. Speeds, and we're going to change this. We calculate up that 80% was 48 millimeters a second. I'm going to keep everything else the same for now. Next thing that I want to change is the model that we're printing. So let's go ahead and change that model out. This particular model was made to do a few different things. One, I wanted to have vertical layers stacking on top of each other straight up so that I could see how the layers were being laid down on top of each other. It does have some curves so that we can see how our speeds are reacting with the corners. And then it also has an area here that stacks, but it stacks in at an angle, so as the layers are adjusting in and or out on your model, we can see how each layer lays on top of each other. But the one thing that we want to do is we're going to go into our profile here. We're going to leave the extruder the same. The layers is going to change. I don't care about the bottom layers. I don't need to waste time looking at that. The first model showed me that that was fine. But I am going to add 2 perimeters. I want to take a look at the inner layer and the outer layer, how they lay together, and if the machine is spacing them out properly to have a nice smooth outer surface. So we've changed that to 2 perimeters. We've changed our speed to 48 millimeters. Now that's going to be 48 millimeters a second on the inside and the outside, so very linear. So let's go ahead and slice this model. Model is sliced. And we'll get it saved onto our SD card and print it and see how it looks. Once the printer's printing the part, I keep an eye on it just to make sure everything's running smooth. If anything happens where it's not printing properly or it didn't stick to the bed, then I can cancel it right away. But otherwise, I'll just let the print run. You don't have to let it run all the way to the top, the 20 millimeters. But I'm going to let it run all the way to the top because I want to see how the outer and inner layer are stacking on with each other. I have found in the past with some filaments that the inner layer, which is printed first, is a lot smoother than the outer layer. And I think that's an issue with the machine's motors not being that accurate and making that space properly. And what I've done to compensate for that, and it's worked beautiful, is I'll print the outer layer first, then the inner layer. Then the outer layer is smooth and clean, and the inner layer has got some, maybe a few bumps or some inconsistencies, but they're hidden and you can't see them. But so far this print's running good. I'm going to let it run till the end, pop it off, and take some close-up pictures and see what we're dealing with. Okay, with the part off the machine and a close inspection, The part actually looks really nice. Temperatures are good. I'm not able to pull the layers apart. They're very strong. If the layers actually pulled apart, then I know that my temperature is too low and I have to increase the temperature itself. The sidewalls are really nice, but I noticed on the front 15-degree taper area, I was feeling with my thumb ridges. Now I know it's not a mechanical issue because those ridges are not on the sidewalls, they're only on the 15-degree taper, which leads me to believe that the motors, when they're printing the inner and outer layers, it's just off just a little bit. It's gotta move in a little bit and then out a little bit each time as it's moving that 15-degree taper up. So that little offset is maybe overlapping the layer behind it, and I'm feeling these bumps. So what I did was I went in and I adjusted the outline direction from outside first and then inside so that it would lay down the first outer layer and then the inner layer. And what that would be doing is if there was a little bit of offset where the inner layer was overlapping the outer layer, we wouldn't see that thickness change. So the outside would be smooth and that thickness change would be shifted into the inside. So after making the change, I resliced it and I went ahead and printed it. And sure enough, after the print was finished and I was taken off the bed, I could not feel that ridge on the outside layer with my thumb, but it was transferred to the inside. So now I know that for this particular filament on my machine at that speed, I'm having much smoother luck printing from the outside in. So now that that part is finished and I'm really happy with the finish, I want to take some measurements because there's a couple of other adjustments that might have to be made. And one of the adjustments is the thickness or the extrusion multiplier. So this extrusion width is set for auto, which is a 0.48 millimeter wall thickness. So having two walls at 0.48 millimeters, the distance should be 0.96 millimeters. And this extrusion multiplier is what you would adjust in order to compensate for this. So if it was extruding more and I was getting a thicker wall, then I would turn this down to thin it out. If the wall was thinner than what it was supposed to be for two layers, then it would increase the multiplier to thicken it up. But on this particular model, we got really lucky, and I guess the temperature we're running and the extrusion speed and movement that we're running, we're getting perfect. Now, is it perfect throughout the whole thing? No, but 0.01 or 0.02 difference between these areas is minuscule. It's not even measurable for these particular parts. So I am super happy with that. Now, the next dimension I want to measure is the height. Now, this one people get this wrong sometimes, and I'm measuring here. My model is 20 millimeters tall, and I'm measuring 20 millimeters. So usually the Z height works out well, but I want to show you something here. I'm going to go ahead and slice this, and I'm going to show you how tall it should be. So the Z is 20 millimeters right down here, and I'm measuring 20 millimeters. Perfect. But let's say that my layer height was different. Let's change this to say I want to speed this up. So I'm going to change my layer height to, I don't know, 0.28 millimeters. Okay, so let's slice it and see what happens. So you notice that the layer height now is 19.88. So after I print this and I measure it, I should not be measuring 20. I should be measuring 19.88. So the layer height's going to dictate the overall height finish. Now, some people will measure cubes and they'll say, oh, it's 20 millimeters, but I'm not getting 20 millimeters. It's this size, so my machine's off. Well, did you check here to see how your layer height has adjusted or changed the height of your part? So always take a look at that to make sure. So now here's our final step. We've gone through, we made some adjustments, we're happy. We're going to start to print some models, but I want to save this. So I want to save all the changes that I've done. So I'm going to save as new, and I'm going to create, let's say I call this XYZ red. Now, anytime I use this particular filament and I'm making a model, I can make changes in here. I can always go back to it. And if I'm going to start a new filament that I've never used before, I'll go ahead and go back to my base profile and I can start to build from there, make my changes. As soon as I'm happy with my changes, I'll save as new, and you'll start to build your print profile library. So to conclude this video, I hope that you see to build a good, strong print profile base, it's just a few simple settings, and it really only took us about 11 grams of material and about 15-20 minutes of our time to get a good, strong start. All the other settings are just fine-tuning of this particular base profile, and they can be tweaked with other models from there. If there's some other setting that you don't understand or you want me to take a look at, please let me know in the comments below. But with this particular start that we've got, I'm going to start to print some things, and if I run into some issues, then I can go into this print profile for this PLA material, make some fine adjustments, and I'm off to the races. Thanks for watching, and see you in the next one.